Alright, I'm going to start off with the basics of the subwoofer design. Um, so I guess I'll show you a bit more in depth of the software I'm using. It's quite old, but a lot of the principles should be the same. Um, so I've entered all the driver properties I could find on the driver I intend to use, uh, which was a Polk DB8 SV. I think just stood for single voice coil, something like that. I think it's no longer sold anymore, but I have a few of those speakers hanging around, and they look good, and so that's why I'm using it. Now the subwoofer design I don't need a big subwoofer. I've had good luck with 8-inch drivers for my entertainment use here in my little room. Anyway, back on track. So you can either get all the like fairly small parameters, which is the most important parameters used in all these calculations. You can either try to get them from the website or manufacturer or whoever you can find them from. Um, One option I used was the DATS, which is a Dayton Audio, uh, like a measuring system. It's like an inbuilt oscilloscope and driver and bunch of measure resistance and capacitance. You can basically get all the parameters of a speaker pretty quickly and easily. So that's where these values have actually come from. They're somewhat close to the manufacturer's specifications for the speaker, but I'm just using what I got from the actual measuring of the speaker. So if you mouse over it, just sort of says what the parameters are and so on. X max, I can't remember what that was, but I'm just going off the top of my head what I think it might be. It's either 9 or 11. Those two values ring a bell, but it doesn't really change anything. All it affects is I'll show you later, but it's going to like affect the air velocity in your ports and such in like small choke points. Uh, anyway, so try to get all these parameters, and that'll greatly increase the accuracy of your simulation. Dimensions, you don't need them, but it just helps give you the not offset, the displacement that the speaker is going to take up in terms of volume. So you do that, build your speaker, or there might even be libraries, especially this software has got a bit of a library of them, but it, of course didn't have my speaker in it. Um, Next thing you want to focus on is actually building the box. This software is like a wizard that you can run through, and it sort of suggests what's best and so on. But I'm just doing it like this. The description, don't worry about that. So you have the most important thing. You can either do a closed or a vented. You're pretty much always going to be doing vented, uh, unless you want a really small subwoofer. Then you're probably going to go with closed. Um, so I guess first value. So this is going to be the volume. There you go. Mouse over will show you what it says. But it's just the volume of your total usable space after all your components are added in. And the second value here is going to be as it says, the volume of the empty box, essentially. Uh, this here will be like the FB. Come on, there you go. Box tuning frequency. So this will all depend on what speaker you use and what frequency you want to ultimately amplify. I've got it locked into my port here, so the dimensions I enter for my port size and the dimension of the volume here is going to ultimately set this. But alternatively, you can uncheck that and you can set it here instead. But I just like to play around with the port dimensions here and see what I can get out of it. I'll tell you a bit more about the port in a second, and pretty much ignore the dimensions here because you're going to build the box to that volume essentially, or that volume technically. So dampening, I never really bother with dampening. It's not really going to affect much, honestly. Just kills your bass a little bit, pretty much. And I'll show you, where is it? Yeah, plot. So I'll show you, all this just gives you all these graphs. Most important one is this normalized amplitude and vent velocity. Oh, there's a bunch in there, let me just clear that. So the driver I'm using maxes out at about 600 watts. So that's going to be like the absolute max power it's going to be pushing. So with this graph here, the vent velocity, that's the velocity of the air going through your vents here, or your ports. So what the vent does, or port, or sometimes called bass reflex tube, or whatever, it's the hole in a subwoofer essentially. It's just a channel where it makes a column of air, and it will invert the phase of whatever's coming out the back end of the subwoofer speaker itself. So you'll get a in phase sound wave coming out of that tube. So it adds to the wave coming out the front side of your speaker. So it gives you a total cumulative boost, making use of that, rear energy on that speaker cone. If any of that makes sense. It's making most efficient use of the energy, essentially, from the speaker. So, yes, you have air traveling through a small tube. So what you can get then is very high velocity air, and very high velocity air makes noise, which you don't want. So where this essentially darkens out is where you're probably going to start to get noise. So it's like a very small peak, which I'm probably never going to reach, but that's fine for me. If you if you increase the surface area of your tube, you're pretty much going to have to increase the length of the tube as well. And the longer your tube, the more you're going to have to try fit it into your box enclosure. So if the tube's longer than your box enclosure, you're going to have to start going with an L shape. Or if an L shape's not even long enough, you're going to have to start zigzagging it, and it just turns into a bit of a nightmare. But I want a subwoofer that is, I think it's about 42 centimeters long, and this is 38 centimeters long, the bass tube, so that's perfect. So this will be fine. I mean, realistically, it's probably going to be driven at like 400 watts maximum. So that's, as you can see, that's replotted under the noise area. So I'll be fine pretty much. So back to the amplitude response. One thing that might note, this option here gives you either all the way from very low frequency to very high, but we don't need that. We're just going from very low to sort of mid-range. So it gives you a broader zoomed in spectrum for your bass here. Same for this. That just sort of stretches out, which we don't want. So the next thing I guess I should talk about with the vents here. So for instance, I've got two vents, they're square. I'll show you the design very quickly. I'm going to redo this design just to show you how it all goes. So you've got two ports here and they're square. And what I was talking about before with the L shape, if your port needs to be longer, it's going to go up here, or if it's even too long for that, you're going to start zigzagging the thing, or it's possibly called a maze as well. But this is like the perfect length for me. As you can see, it stops right there. Just one single sheet, very easy to make. So the width I want of my subwoofer is like 32 centimeters wide is what I want. So if we do the 136 millimeters, we times that by 2 because we've got two ports, and we have that little, we have 16 millimeters of MDF in the middle. Then we have another 16 millimeters on one side and another 16 millimeters on the other side for the walls. So that gives us 32 or 320 millimeters or 32 centimeters, which is exactly what I want. So just keep that in mind when you're doing your, well, that's height, but whatever dimension, width will do. And width, sorry, height. It's meant to be height. I've got them mixed around, of 25 millimeters or 2.5 centimeters tall for the port. Interior, don't really worry about it. Just make sure you get your placement of the speaker right. I'm doing a rear mount. This should be calculated, but for some reason it's not doing it. But it doesn't matter because I'll be figuring that out in the design. Just got to keep this magic value here, so 56 liters. So if we we've entered in all that, and we do our plot, and we'll get the essentially the, as it says, the amplitude that we'll be getting, the volume that we'll be getting from our subwoofer. So this graph here is a bit logarithmic. So 10 hertz, you're never going to hear that really. 20 hertz is like the lowest you're really going to want to aim for. But 30 hertz, which is this line here, is a good trade-off because it takes a lot of space and a lot of very special drivers to go down all the way to 20 hertz. This will still push out 20 hertz. It's just going to be at a much more reduced volume. But 30 hertz here, you can see we have a nice sweet peak. So that'll allow us to like shake the room and get a good high chest thumping bass out of it. And you can see it's not perfectly flat. But if I wanted to flatten this out, I would lose this very low end. I'll show you what I mean by like flattening it out. One way to flatten it out is to sort of add in the filling here, which is literally just fluff. So if I'll change the color of this. If I replot this, well, that does flatten it out a bit. But as you can see, it's just killed that 30 hertz bass spike we get. I mean, it's up to you. What do you want? Do you want a perfect response, or do you want to feel a nice thump in your chest from drums and stuff like that? It's up to you. Just replot that. Oops. Go back to my box. I don't want any filling. So there we go. And don't worry about anything here because it's a subwoofer, so it's pretty much going to be cutting off at around the 150 hertz, maybe even 200 hertz. So you're going to get like a curve dropping off like this. And the other speakers I have, which are like the two-way sort of mid-bass and high range, will be taking up that slack. So that's the basics of how I'm getting this design and my volumes and such. So we'll go back to this sort of magic value of 56 liters is what we're aiming for in usable space. Here we go. So in terms of usable space, so if we use our measuring tool here, we measure from the top of the inside roof to the bottom of the, so we don't want to do the very bottom here, we actually want to do the top of the vent, because technically the volume inside the vent is not our total, our usable volume, sorry. So we've got 47.7 centimeters, so 47.7 times the other volume dimension we have is these two. So from inside to inside, so that's 40.2. 40.2. And the final one is our from one side to the other side, which is 28.8, 28.8. That gives us a big number. So that is in cubic centimeters, because I was doing this all in centimeters. So, if you do it all in millimeters, that will be a much bigger number, and it will be cubic millimeters. So, just punch that number into Google and say that many cubic centimeters to liters, and that gives me 55 liters, which is actually a tiny bit out, because I want 56 liters, but that doesn't matter. We'll just actually, it probably is correct, because this little bit of volume here, which is probably equal to about 1 liter, will add that extra liter. So this is about 56 liters. Now I'll start this whole design from scratch and show you how to do it all. Alright, so we have a new blank document here. So what I started off with is, you decide whether you want to work via internal or external dimensions. So I was doing internal because that gave me my volume easier. So I wanted an ideal height of 55 centimeters from top to bottom of the subwoofer. So we have 55 centimeters. We subtract 1.6, which is the thickness of our MDF, and another 1.6 because there's top and bottom. So that left me with 51.8 centimeters. So that was going to be my internal height dimension. So we'll create a sketch. So one rectangle, just go from the center. So 51.8 centimeters. Yep. Zoom out. So the width was just do the same process. I wanted a 32 centimeter. Actually, you can do the math right here, I believe. So you want 32 centimeters. So you subtract 1.6 and another 1.6 and enter in centimeters. That's going to do it all in millimeters. So 320 millimeters. Subtract 16 millimeters and another 16 millimeters. That gives you 288. So that's going to be our inner dimensions of that axis. So now what you can do is you can offset all that. So select the outer area, press O, do your 16 millimeter offset. Now you've got to figure out how you're going to join this together. Are you going to use a 45 degree join with another 45 degree join, which I'm not, or straight edge to straight edge, which is what I'm going to do. Because once again, I intend to veneer the sides of these. But if you're not going to veneer it and just raw paint the whole thing, just a flat paint, then you probably want to do the 45 degree angle, because then you only have to worry about that little corner there, and it'll be pretty smooth. Whereas if you have corners on flats, you're always going to have to bog it up, or really give it a good sand and coating, which I can still do if I can't get enough veneer from it. So these are going to be my sections, like sides and top. So next step I want to do is figure out how far I'm going to extrude these. Oops, don't want that, I want that. Actually, first I'll extrude just these two, because I want these as separate panels. If I do them all in one, it'll just be a solid box. So now I need to figure out the depth that I want. once again, you figure out your total volume versus, the dimensions you want for your subwoofer in the end. So I wanted, I'll show you a bit more in the end, but 418 millimeters is how far I need this to extrude out. And I'll show this again and extrude these to the same. See, what I'll do is I'll extrude to here and new body. So if I need to edit this distance, all I have to do is edit the distance here and the rest will follow. The next thing I need to do is design the inner door that goes in the back. So I've already got this selection here. So remember, 16 millimeters. That's going to do a join. We want a new body. And why can I see nothing? Let me just hide that. No, it's there. Guess while we're doing this, we'll name these things. Oops. Get rid of the capitals. P just stands for panel. Just making up this naming scheme on the fly. Go back to perspective. I hate that isometric view. Now we'll do the front facade. So I will do another sketch. I will edit on top of this sketch. Because if you want to change these dimensions, you just stack it all up in this one sketch. So if you make one little change, the rest should cascade and properly apply to your model parametrically without stuffing up. So we're going to do another offset. So remember, we're working from our inner dimensions here. So we've got our 16. Now remember, the first set of speakers I did, they have that front face which has like a little offset at the front, a little overhang, just nice little facade. So say we want an extra 5 millimeters. I think that looks pretty good. As I said, we can change it. So 6 plus 5 millimeters. Let's just pull all these dimensions out. So that's looking neat. Now we'll select all of it. Actually, wait a second, finish that. If you try to do an offset while you're editing that sketch is like back in the timeline, right back here, so it hasn't got all these other bodies that you can use, and I'll show you why I need these bodies. So I select, so I just hit body so I can easily select it. Now I can show the bodies again. So I press Q to do the extrusion. Now I want to start it from an offset. So just from this panel here. And remember, we want a new body. And we want 16 millimeters. Wait, what's that doing? What? Oh, from object, sorry. From there. Alright. So I'll just hide all the bodies. So it lets me easily select that. Then I'll show the bodies again. I press Q to extrude again. So I want to start from an object, sorry. So from the top here, remember this is parametrically set. So as we adjust our initial extrude here, that'll adjust everything appropriately. It's going to be, no, we want the distance here. We'll just edit it here, 16 millimeters, and we want it as a new body. So that's given our front face here with our nice little offset. Now the next stage, I guess, will be to add our hole. So we can now just work from this panel. So I'll start a sketch on this panel. So we'll do a circle. So I'm just, selecting the center here, so that gives me a snap to center. Now I'll just get the dimension of this. So this is a diameter of 195 millimeters. So you can change all this later. Now just position, you can have the position wherever you want, as long as it doesn't intercept the vents you're going to have here. I think around there will look pretty good. Then we'll do the vent holes here. So we won't bother with getting this position, just plop down a square. Can I do from this line to that? I can, awesome. Now can I use 0? I cannot. So I'll just use 0.0. So I'll just do pretty much negligible. There we go. So we can do from these sections. I'm sure there's a better way to do this, but whatever. So now this square will parametrically adjust. We'll get our height here. So 25. And we have a center pillar here as well. So that's automatically selecting the center. That's not. Okay, 16, and the height doesn't matter. So finish the sketch. Select these. And we want to cut. Let me get rid of a panel. Distance, so all the way to the back here. Just make sure it's only cutting this panel. We'll rename this face. So there we go. So now let's experiment and try to, can I change that? Yes, I can. So just say we wanted to make this 350. And that's all changed. That's all correct. And we'll undo that. So yep, that's working pretty good. Where did the value go for here? Let's just change this to like 700. So, yes, of course. Because when I drew the lines here, it was just snapping to this. So what you want to do is lock it to it with a rule. But yeah, I can't be bothered doing that for now. Actually, I'll show you how to do it. So I believe it's collinear. Guess you just want that to be collinear with that. this to be collinear with that. So now, if we change this to 700, there we go. So now that properly changes. There you go. Our thing here's disappeared, and I know exactly why. Because in our sketch here, it's just randomly placed there. It's not concentric to anything. So once again, we can go to collinear. That with that. There we go. That's what we want, collinear. So as this changes, this will match it. You know, make this collinear with this as well. There we go. That's much cleaner. So now as we adjust this, say 800, it should all be, there we go. So that's all adjusting appropriately. So that's how the parametrics all set up, so you can adjust those values and the rest should change appropriately. Next thing we want to do, I guess we want to finalize this panel. So we want there we go. We want chamfers on here. 8mm look alright? Yeah, it looks fine. I want to chamfer this. Ten. Or should I just stick with the same 8? I'll just stick with the same 8 for now. Be careful if you chamfer the port. That will actually affect your tuning a tiny bit, but it's so small that it's barely really affecting it. It might look good actually if I apply a bit of a chamfer there. Although I can't actually chamfer in there because the bit will it'll end up with a big round section there. So I'm going to have radius 6mm radiuses in here anyway, because the bit I'm going to use to cut it will be 6mm diameter. So of course it can't cut a perfect square. Talking about radius, we'll radius these edges. So just select them. I'll fillet it. So whatever looks nice. 8. Oh, we'll go bigger. We'll go 12. Maybe 10. And we'll add the little radiuses in here. Bit awkward, but whatever. So 6mm. Now is that? No, that's radius, not diameter. So you want 3mm radius, which equals a 6mm diameter. So there we go. That's how that looks. So that's roughly what the box is going to look like on the outside. We'll do the port next. So the port's super simple. I will. Yeah, so we just want to start a sketch here. Just move this at an angle. Just drawing anywhere, a line matching these. Now you can like overextend it, it's not going to matter at all. It just depends on what you select. Oops, I don't want to select that center because that'll be a constraint that I'll have to deal with. Just make sure you know you're at 0 degrees. Okay, so now we'll apply our constraints. So I want this to be constrained with the top of that port there. And that's already tied to this, and this is already tied to that. So now we just want to set our height here, which is of course 16 millimeters, because we'll use the same thickness MDF for that. We'll go to perspective again. Probably could use thinner sheet. Nah. So yeah, another line down here. Another line down here. Just make it that curlinear with this, and that curlinear with this. Ah yes, and we're going to need to put another line. I'll tie it with the bottom of these ports, so that will now adjust with these if you move it all. So we'll extrude this in 2 goes. So remember if we go back to this program, and for the vents, so that length is the total length, yep, as it says. So we're going to have to subtract 16 millimeters from that, because this 16 millimeters of our front face is adding to that port. So we'll press Q for extrusion. So it was 380 millimeters. Subtract 16, and we want a new body again. So that's the one portion, and we'll do this little section here as well. So press Q, 380 minus 16, new body, and bam, now I can hide that again. That's pretty much the box design. There'll be more I'll add to it next time, like bracing, the binding post terminals in the back with like a sunken cavity, and anything else I can think of, and I'll start the material design and the cam profiles. I'll start that next time.